Selamat siang Bapak Ibu rekan-rekan semua, saya Amanda MC pada kegiatan kita siang ini. Mohon bersabar menunggu peserta yang lain, tetap pastikan mic Anda dalam posisi mute selama kegiatan berlangsung. Kita akan memulai 5 menit lagi. Selamat siang Bapak Ibu rekan-rekan. Kita akan memulai rangkaian acara webinar kita. Terima kasih atas kehadirannya. Dalam kesempatan yang baik ini, kita akan membahas tema mengenai Artificial Intelligence Highlights. Ladies and gentlemen, thank you for joining our webinar series. Today we will discuss about Artificial Intelligence Highlights. Kegiatan ini didukung oleh Aptiknas, Asosiasi Pengusaha Teknologi Informasi dan Komunikasi Nasional, serta IAIS, Indonesia Artificial Intelligence Society. Diadakan oleh Event Cerdas, mitra transformasi digital Anda. Didukung juga oleh media partner biskom.web.id, portal teknologi informasi komunikasi dan hukum. This event is supported by Aptiknas, Indonesia ICT Business Association, Event Cerdas, your digital transformation partner, and biskom.web.id, IT and Law Portal. Webinar ini akan dimoderator oleh Fanky Christian, selaku Ketua Aptiknas DKI Jakarta. This webinar will be moderated by Fanky Christian, as Regional Chairman of Aptiknas Jakarta. Silakan Pak Fanky.
Terima kasih Amanda, selamat siang Bapak Ibu sekalian. Selamat bertemu kembali dalam kegiatan webinar kita yang seyogyanya biasanya diadakan setiap hari Kamis ya, tapi minggu ini Kamis libur, jadi kita geser ke hari Jumat ya. Dan kali ini kita akan coba angkat satu tema lagi, Artificial Intelligence Highlights. Jadi kami mengundang para speaker, narasumber yang memang memiliki solusi terkait dengan Artificial Intelligence untuk bisa menyampaikan materi, presentasi, perkenalan, produk dan solusinya di acara kita ya. Nah jadi saya introducing lagi Indonesia Artificial Intelligence Society. Jadi ini komunitas Artificial Intelligence yang terbesar di Indonesia. Apabila Bapak Ibu rekan-rekan belum bergabung menjadi bagian dari IAIS, silakan bergabung ke IAIS karena nanti di sana bisa bertemu dengan teman-teman yang memang punya interest terkait dengan industri terkait dengan artificial intelligence. Nah, yang seperti yang Bapak Ibu rekan-rekan ketahui, kita juga telah memiliki strategi nasional terkait dengan artificial intelligence ya, dan ini selaras dengan apa yang selama ini coba disuarakan oleh IAIS. Di dalam IAIS kami juga banyak melakukan pengembangan talenta cerdasan buatan atau artificial intelligence, dan dalam hal ini saya mewakili direktorat yang namanya industri kolaborasi industri ya, atau industry collaboration. Nah, dalam kesempatan siang kali ini kita telah kita ada dua speaker yang akan berbagi dengan kita ya dalam kesempatan siang kali ini. Saya ingin memperkenalkan dulu untuk ke Bapak Ibu sekalian agar bisa berkenalan ya dengan para speaker kita ya sebentar ya. Yang pertama, jadi hadir bersama dengan kita, saya coba highlight dulu Mr. Philip Tan ya. And Mr. Vijay. Let's spotlight. Okay. So Mr. Vijay Sarashetti, the founder and CTO from Arogya AI. Yeah. Then will be our first speaker. Hello, Vijay.
Myself. Yeah, there you go.
Yeah.
Okay.
Okay, this is Mr. Vijay, and then the next speaker will be Mr. Philip Tan. Mr. Philip Tan is General Manager for Southeast Asia of Graphcore, yeah? Okay, the first will be Mr. Vijay first, and then after that, Mr. Philip. After Mr. Philip, we do the Q&A, ya. Jadi Bapak Ibu rekan-rekan silakan nanti apabila ada pertanyaan, if you have any question, you just type the question on the chat. We will discuss the question after the presentation. Mr. Vijay presentation, it will take around 30 minutes, and then Mr. Philip around 45 minutes. So stay tuned. Please enjoy the presentation, and we will do the Q&A after the speakers presented their materials. Okay, for the first speaker is Mr. Vijay Sarashetti, founder and CTO Arogya AI, will be discussing about supply chain challenges in healthcare, how Arogya AI can help. Vijay, the screen is yours.
All right, thank you very much. Hello all, a very good afternoon. I know it's Friday evening, and from the place where I come, Friday evening is usually, nobody works. That is from the United States, right? Especially in the banking division. But Jakarta is different and fun, nice, fun place to be in. I am actually talking from Jakarta. Hello to everybody who is on the call, and thank you for attending. So I might introduce myself briefly. I've been in this industry, that is in technology, for the past 36 years. Most of it has been in the United States. Came to Indonesia about 4 years ago to give a similar kind of presentation on blockchain, AI, and IoT. And my current partner, Mr. Victor Fungkong, asked me if I would be interested to start something here in Indonesia. And I said, sure, why not? And then I returned to the United States, came back to Indonesia. So I've been here for 4 years and loving every minute of it. It's been a very pleasant experience, and I hope to succeed with the things that we are doing here, both on a personal level and at a national level as well. All right, without further ado, let me start the presentation, and let's see if I can share my screen. Yeah. All right, so to start off with, right, artificial intelligence, we all think about it in many, many ways. But when it comes to industrial application, change is not easy. Everybody has the same problem. That is, the data is not ready for artificial intelligence. It's not ready. It is not time series based. It has multiple sources. There is sparse data. There is attributes, features, and all of the things that we need are not there. So the big question is how to do it. So Arogya AI started with that principle itself, or whether with the challenge that change will not come if we wait for some other person or some other company or some other time. Arogya AI is the change that the world needs and is waiting for. We truly believe this and work hard to make sure that we do not disappoint. And the other one is by Peter Drucker, one of the oldest management gurus of all times. The greatest danger in times of change is not the change itself, it is to act with yesterday's logic. So why do we say that and why do we appreciate it? Because artificial intelligence is going to change the way we do business, the way we manage things today. And if we are not willing to change, and if we are still thinking about yesterday's logic, it's going to be very difficult for companies to succeed without actually appreciating the logic and applying it in their industry. So what's our worldview, right? The world is changing rapidly. So Arogya AI worldview is AI for IA. So I think some very key words have been coined and I'm using them. Some of them are mine, some of them belong to the industry. So I love this, that is AI for IA, for intelligent automation. So what is it that we are trying to automate? Technology is making rapid changes, and unlike before, the frequency and time taken for these changes is rapidly undergoing a time crunch, and thanks to artificial intelligence. If I were to say that 2025 is going to look completely different than what 2022 is, please don't be surprised, because now AI is helping build AI, of course, with a little bit of human assistance, very little. So, and it is rapidly making changes. And when machines start making changes, it is very rapid. If you think about any parallels, whether it is farming, whether it is growing stuff, or whether it is manufacturing, or whether it is driving cars, if you look at what is happening, so let's think about it. From horse carts to motor cars took somewhere around about 3 to 4 centuries. But from cars to automated self-driving cars hardly took 70 to 80 years. That is, that is converting in 1/10 of a time. We are doing so many things so much more rapidly. And what's driving this change? Machines can now think and make decisions faster, more accurate, cost-effective, and above all, independent of emotions. They are available to serve mankind 24/7, 365. They can now communicate inter-machine, that is, two or separate AI machines can talk, or intra-machine, two or more algorithms in a single machine. They actually talk. Believe it or not, they talk. All the bots that you're looking at, Google bot, WhatsApp bot, Telegram bot, they actually talk to you, and they hold conversations so intelligently. And some marketing people are using this bots. Bank of America is a very good example. Hello, Erica. Amazon Alexa is another good example. So we are also building something called ANA, Arogya Network Analysis, and you can talk, and that's what is also driving change. Based on these decisions, they can automate entire process chains, not just one part of it, one aspect of it, but entire automation. Automation based on such Turing complete AI networks are now functional and going live. Weather, war games, surveillance, autonomous cars, Amazon are just few examples, completely automated. Weather is, believe it or not, weather is completely automated. Weather forecasting has become completely automated. Previously, you required a weatherman to look at low pressure zones, high pressure zones in Texas, in Florida, in Jakarta, in Singapore, and then derive at where the wind is moving, where the cyclone is moving. All of it is now being done by machines. All the weatherman is now doing is, honestly, and please don't quote me on that, is he just comes and tells what the machine has already told him. So that's what it is. Now, Arogya AI is part of this changing world, and its core philosophy is to automate the healthcare supply chain. It is complex, it is difficult, and yet it will be the most fulfilling AI problem to solve in this decade and this century. Why? Because health matters. So that is what Arogya is about. We are using automation, artificial intelligence to intelligently automate the healthcare supply chain. And that in itself is a massive challenge. We are willing to do it. So what are the problems in supply chain? Let's take an age-old problem looking for a new world solution. Supply chain is an important aspect in any business, more so in healthcare. So I'm not going to go into deep details, but how many times has anybody gone to a healthcare provider and he doesn't have this, he doesn't have that, oh, we ran out of stock, I'm going to give you a substitute, this is what it is, or the doctor prescribes something and then you run to the pharmacy and he's out of stock, and so on and so forth, continuously happening. Sometimes expired, sometimes they don't have the proper brand, or things like that keep on happening. So that's a problem that we can solve. It all begins with inventory management. So supply chain, we have divided. So there are some things in this deck which I'm just going to talk personally. We have divided supply chain into 4 major verticals. Vertical 1 is the demand side. Vertical 4 is the supply side. In between the demand side and the supply side is the finance side and the logistics side. So what we are focusing right now with Arogya is the demand side. So inventory management, order management, procurement is all about demand. And if you know what to order, when to order, and how much to order, you're literally telling the whole world that my supply chain can be now optimized and it now can be automated. We strongly believe, and this is one of our very firm beliefs, that we strongly believe that inventory is not a static number with static processes and static rules. To Arogya, inventory is a dynamic number in a dynamic process that requires dynamic decisions. A big statement. What does that mean? Coronavirus or COVID is a very good example. Suddenly when things start changing, oxygen comes into demand, respiratory medication comes into demand. How can we predict that demand? We cannot predict it 100%, but there are patterns emerging, patterns that humans can miss. The way inventory used, we can take these patterns and say that these things are changing. So there is a very dynamic pattern that emerges on a day-to-day basis as inventory is being consumed. So how do we do it? Using artificial intelligence brings about this dynamism to every aspect of the inventory management. I'll leave the rest, we'll share this presentation later. So I think, so what do we solve? Arogya's design principles, designed to solve fundamental supply chain issues, designed to extend and expand with ease, designed for growth nationally as well as internationally, designed to cover all touch points in supply chains, designed for all level of healthcare providers. We'll discuss that in detail later. Designed to create a network marketplace, providing automation at every junction in the network. It's no touch, seamless, frictionless. I'll tell you more about no touch, seamless, frictionless. Let's say a hospital is using paracetamol. The AI engine literally is tracking the usage of paracetamol, and at a certain point in time, if the pattern is changing, if the behavior is changing, something is changing, it knows when I'm going to be under stock, what is my lead time, and what is my rate of consumption, and it can automatically order it from a supplier. And the supplier, knowing full well that, okay, this order has come automatically, he can get it funded from a bank and can get it insured from an insuring agency and the logistics provider. Everything happens automatically. And these are systems, multiple systems talking to each other. So we say that this is no touch, seamless, and frictionless. So paracetamol gets over in a hospital and suddenly it is replenished. Again, you have paracetamol. So without anybody knowing it, it's already there. So it gets over, it gets replenished. So that's the idea behind this. And this, of course, when you have this kind of automation, efficiency, effectiveness, and economy are automatic. And also it saves time, money, resources by using AI intelligently. These are our design principles. And we are systematic in our approach, addressing all aspects of AI. To us, AI is not a buzzword, it's a powerful paradigm. Let's go to component 4. For a true AI product solution, we have AI architects who have capabilities of understanding these 3 components while fully exploiting and integrating them: data science, machine learning, optimization, and adaptive systems. So these are some very key words in artificial intelligence, which you will keep on hearing again and again, that our systems are adaptive, we have optimized everything, we have machine learning, we have data science, we have decision scientists. So this is a new field that is coming up as well, decision scientists. So we already have decision scientists. What decision to take if a certain event happens is something that AI cannot do. So what we have done is we have spoken to doctors, we have spoken to other experienced people and said, okay, these are some of the decisions that can be taken. And then it presents these decisions to the doctor, to the physician, and he can now say, okay, fine, I agree with this decision and I can go ahead. Why Arogya, right? Designed with the future in mind, AI ready, automation and integration. It is cost effective, alternative to costlier alternatives throughout, from implementation to maintain to support and enhancements, built on today's technologies framework. It is very, very compatible with today's ecosystem, and it is fully featured. So this is how we look at the market. So there is actual inventory, which is the physical domain. So in the physical domain, so let me explain this picture very clearly here, because then this is what is the foundation of how we operate artificial intelligence into this environment. So actual inventory is the physical domain. It is ruled by or governed by processes, people, systems, technology, and the people in here are SAP, SaaS, Microsoft, and others. Then there is inventory management, which is the logical domain, wherein you have platform, services, algorithms, reference data, and you have Arogya AI. Then there are models here, and this is the insight intelligence domain. This is the new domain that we are creating, we are building, and we are helping healthcare providers to get in here. From the other side of it is there is the transaction data, which is the transaction domain. So all procurement, logistics, settlement, Arogya. So the products that we have is Aurogai Marketplace, Arogya Inventory Manager and Order Manager, Arogya Logistics Manager and Procurement Manager, and Arogya SaaS. We also have a SaaS model, which is software as a service, or AI as a service model, where small pharmacies and small clinics can also use our AI by just uploading data. So they don't have to do it on an Excel spreadsheet. They can use our engine to get that done. So both of these things, we take data from the right-hand side and all of this from the left-hand side, and we create what is the evolving market, which is all about insight intelligence domain. We are also adding a simulator, and we also have Anna, which is our news and network analysis deck. So at a glance, So this is a very busy picture, but I think I'm going to spend the next 5 minutes explaining this picture. And this one single picture literally tells you what Arogya is about and what artificial intelligence in supply chain is. So let's start from here. So there is operations, which is purchasing. In any healthcare provider's world, there is a purchasing, which is taken by Arogya, which can help him through Aurogai Inventory Manager. This is 3 fundamental questions. If you break down any purchasing, and this is not just healthcare, right? Even in your life, even in your personal life, when you want to buy something, there are only 3 questions that you have: what to order, when to order, and how much to order, right? It's whether it's in the kitchen, whether it's in a healthcare, whether it's in a hospital, wherever it is, right? And for that, what do you need? You need projections, daily, weekly, monthly, yearly, and you need a financial planner. So we help you do that: what to order, when to order, how much to order. Then after you have decided all of that, how all these 3 questions, the next 2 questions that you have is who to order it from and how much to pay. So you have supplier profiling and supplier management. So Arogya.ai's inventory manager and order manager, these are the 2 products which can help you do that using artificial intelligence and using all of your data. So in 2020 and 2021, we built all of this. Now, also, we are as I said, we are automating this. So to connect these 2, what we have is a marketplace, that is Aurogai Marketplace, which has a department storefront, fully functional. You can onboard your pharma, you can onboard your suppliers, you can check your stock in a categorized manner, you can raise requests, and you can connect the central hospitals. So if you are a group of 7 hospitals or 8 hospitals, you can connect centrally, and you can connect to procure, pay, and manage. All of this is available through our marketplace. So this completes the entire automation chain. So you have supplies being, demand side being consumed, and here you are again replenishing your stock. Now, what we are working on is in 2021 and 2022 is inventory analysis and what if analysis. So what is inventory analysis? Most hospitals might say, I don't need all of this. Can you analyze my inventory and tell me what's wrong with it? How can I optimize it? What can I do? Because there's a lot of requests coming from healthcare providers to do that. So we can do that as well. How did you get here? Demand issues, supplies issues. How efficient are you? We can define your efficiencies. We can calculate your efficiencies, your reasons for your inefficiencies. How much is this costing you? And what can you do to fix this? How much will it cost to fix? How much will it save? So that's one part of the story. Then you have a what if analysis: financial restriction, under budget, additional patients, demand simulation, COVID or other outbreaks, similar situations, and supply simulation. And we are actually making that happen. Not yet. So Anna, what is happening? How will it affect supply chain, price, availability, lead time? Will it affect my inventory? Also, for budget and optimizing and planning, we have forecasts by item, by category, by supplier, and by department, and a planning calendar. In year 2022 and year 2023, as we go towards automation, we will provide what is called as Arogya Live and Arogya Connect, which is a full feature from consumption to replenishment, enabling no-touch, seamless, frictionless automation. And Arogya Connect, which will connect financial institutions, insurance, customs, regulator, global logistics, the ecosystem of the future. So we realize our end goal is automation, but we cannot get here if I do not have 1, 2, 3, and 4, and 5. If I don't have this, I cannot create this. So that's the reason why we have faced this one thing at a time, one place at a time, and going towards full automation. Adding to our strength, H2O.ai is our partner. Our entire platform is built on H2O.ai. H2O.ai is a world leader and it's in the likes of Amazon, Microsoft, and Google Analytics, all of them. And H2O.ai is another such platform. Fantastic platform, and they've been kind enough to help us to get to where we are. Very easy to use. And they will also they're also going to help us to brand and resell our solution. So having said this, and that's a brief introduction, and I will, because this is, I think many of you are AI people here who are interested in it, and this is from the business domain. I will show you a couple of slides on this one, but this is what it is. And to every person who is here and everybody else in the world, I ask this question: if not now, then when? When are we going to do this? If not us, then who, right? So thank you for listening. It was our pleasure to show you what tomorrow will look like. We hope that you become a part of this amazing journey. So let me share my 2 more slides. I still think, do I have time or am I up, Pa?
Yeah, go ahead, go ahead.
Okay. Okay, so in the previous deck, you saw all of the high level stuff that we are doing. And here is how we are. So this is how we look at the world of healthcare. So this is a very nice eye opener for everybody here. And as this is an AI society, this is how we draw our diagrams. So we look at a hospital from a very structural point of view. As you can see, the core healthcare is here. There are hospital services, medical records, inventory management, finance and accounting. Supporting is employee management, procurement, and there is insurance. I don't know why I blanked this out, but there is insurance here. So the data infrastructure, I have Mr. Tan here on the call, and he will be very interested to see this as well in the data infrastructure part of it. So the data infrastructure, as far as hospitals are concerned right now, have patient data, supplier data, HR data, operational data, all of these data they have. They have all this data. But we in Arogya are interested in the supplier data, inventory data, and reference data. Reference data, we will provide that. So 1 and 2. And on the other side, you have front office, which is patient registration, queue form management, pharmacy, and billing. So what is different about Arogya is this. Previously, what used to happen is, based on 1 and 2, it would go directly to here, to the inventory manager, and then to the procurement manager. And he would look at screens and everything and so on and so forth. But now what is happening is 1, 2, and 3 directly go to 4 and into analytics, and 4 directs 5 and 6. So this is the brand new chain that we have created. So rather than 1, 2, and 3 going to inventory manager and procurement manager, it now goes to 1, 2, and 3 goes to 4, and then goes to 5 and 6. So that's how we are changing it. Now, here is a very interesting picture, is what companies think AI looks like. Data, AI, value. But what actually is, it's this. Data is, you have to select the data, you have to source it, you have to synthesize it, and then the data science part of it does all of the data engineering and the modeling, which is exploration, cleaning, normalizing it, and then doing the feature engineering, and then scale it, and then model it to do the selection, training, evaluation, and tuning it. And finally, you get value through the operationalization, through registration, deployment, and modeling, and so on and so forth, right? So this is how we look at AI and how actually this operates. So to do that, how have we completed our system? So we have big data experts. We do all of the cleaning, feature extraction for any healthcare provider, no matter what their size, how much data. We can take 3 years data, 4 years data. We can do all of the cleaning. We do all of the feature attraction, and we make it AI ready. So this is your big data experts. We have that as a service. Then our data scientists, we have already created our models. We build our models, and we also have external data sources that we can add to these models. So, and finally, our AI engineers take these models, export this, update, and retrain models as required, and we have our AI run nodes. This entire thing, the AI engineers, the models, and AI run nodes right now on today runs on H2O platform, and this is where we are. So this is high volume real-time operational data. Finally, all of this goes to an output server, which is managed by operations and support. And finally, you have your dashboards, insights, predictions, prescriptions, everything happens in there. So data can come from your business systems, and it also gets into your data API, and the output is it can go directly to your apps and data. So this is our infrastructure part of it. This was your business structure part of it. This was your infrastructure part of it. And this is your logical flow. So we are looking at how do we do this, right? We upload raw inventory data. We put in raw inventory data. We take the raw data, inventory logs table. We do the data assessment and data analysis, clean data, drop data. This is the data pre-processing part of it. We transform the data, that is data translation and transformation. All of this is pre-cooked. Right now, we have all the algorithms running in. We know the schema. We know all of this. 2 years has taught us quite a lot, and we have changed our schema to get there. So then here are your in algorithms and out, demand sensing and consumption prediction forecast, inventory metrics calculation, inventory optimization models, rating scoring based on items. So we have all of this data and prediction table, metrics table, optimization output table, and scoring and rating table. And then we have the inventory analyzer. We look at the past and the present. I am inside inventory metrics, consumption rate, and then finally the inventory manager. This is where all of the forecast, stock on hand, demands. So how much did you sell? How much are you going to sell? Cost per item, order quantity, data store, everything happens right here. And then finally, once you have this, you know, under stock and overstock, that goes to order manager, and that goes to Arogya Live. And this is Arogya Live. Again, I'm not going to go through this whole thing. As I said, I'll share this. So we are also building an efficiency model. How much time, once paracetamol was over, how much time did our engine take time to recognize that it is going to get over? How much time did it spend in procurement? How much time did it spend in finance? How much time did it spend with the supplier? All of that can be measured. All of the data, all of the timestamps and the data are used to build an efficiency model. And here is the fun part of it. Usually when we talk about efficiency, we talk about departments, we talk about hospitals. Believe it or not, Arogya changes that. It changes the efficiency model, not only by department, not only by physician, not only by the healthcare provider, not only by the supplier, but at a drug level, at every single drug. And usually hospitals have somewhere around about 8,000 to 12,000 drugs and items in their inventory. So just think about it, that we can segregate them, which are the most efficient, which are most efficiently ordered, and which are most inefficiently ordered. So what we are doing is we are not only giving them a roadmap, but we are also giving them numbers which they can act on and build upon their efficiencies. So at the highest level, we do the data pre-processing, feature engineering, custom recipes, model training, model fine-tuning to give what? Demand forecasting model, capacity utilization model, price quantity optimization, supplier performance, supply chain modeling, idle stock, utilization rate, order level forecasting. Conventionally, how did they do it? Business rules engines. If this happens, then do this. If this happens, then do this. If this happens. And some of these business rules have not changed for the last 3 or 4 years. And these are also based on reorder levels or schedules, and it's a very reactive process based on instantaneous demands. AI driven is forecasted based on past windows, performance based. Every SKU supplier is rated and ranked, and it is highly proactive based on projected demand. So that's the change that we are bringing. This is data where it all begins, and this is how we do it. So data is converted into information, information is converted into intelligence, and intelligence is converted into insight. And then finally, what is there is the economic order quantity. What is the most economic order quantity without bringing a patient at risk, without bringing a doctor at risk, without bringing the healthcare provider at risk? What is the economic order quantity? That's the end. That's the one single number. That's the magic number which the whole world wants to have. And we hope that we can provide that number. So that's the end of the presentation. And this is all the same thing in depth. thank you very much for listening. And I think I'll hand this over back to Fanky.
Yeah.
And await your questions and answers at the end of the session.
Thank you, Vijay. That's very enlightening for me also, because healthcare is one of the thing that very the growing now, yeah, during the pandemic. Okay, stay tuned. I will invite Mr. Philip Tan to share the presentation. Mr. Philip, where are you now?
I'm here.
Oh, where are you? Okay, I
Yep.
spotlight you now, yeah.
Yep.
Okay, go ahead.
Okay, hold on a second. Yep.
Bapak Ibu silakan kalau ada pertanyaan sampaikan aja di kolom chat, nanti kita bahas setelah sesi Mr. Philip ya. Thank you. Go ahead, Mr. Philip.
Thank you, Fanky. Very good afternoon to everybody. My name is Philip and I'm from Graphcore. And today's presentation for my portion, it will be pretty long. It will be about 50 minutes. And the first half of it tend to be quite technical. They tend to get quite detailed. So if you are the type that don't really care much about technical details, please bear with me. And because the fun part is at the back where I'll share some of our customer use cases as well. Right, so very great to be here, and I see a very large audience here. Very good afternoon. Today, I want to give a quick introduction about Graphcore, who we are, and how our breakthrough in AI processor architecture are enabling huge advance in machine learning. Graphcore has developed this device that we call IPU, Intelligence Processing Unit, so that innovators can create the next breakthrough in machine intelligence. Right. In fact, that is our mission statement. It is an entirely new hardware architecture. It is designed from the ground up for AI and machine learning workload. It is very, very favorable to the more advanced, very high accuracy models. That is where the future of machine learning is heading. We're very excited about what we have built, and we want to look forward to work with you to build the next generation of machine intelligence systems. Before I start, I'd like to point to a research essay here that introduces the term hardware lottery. Right, hardware lottery to describe when a research idea wins, not because it is the best idea, but simply because most of the time it is suited to the available hardware and software that is available in the market. Meaning to say that there are a lot of times there could be better research ideas, but the type of hardware and the software to support those ideas were not available at that time. So our starting premise from our company is that we wanted to create a new approach to AI hardware to meet future demands. So Graphcore builds products, both hardware and software, for the demands of today, tomorrow in machine learning and AI. We design our silicon specifically for the needs of machine learning and AI, and we call these processors Intelligence Processing Units, or IPUs. So IPUs are radically very different from historical processor architecture like CPU or GPU, right? The IPU is designed to be similar to the makeup of our brains because we put processing, memory, and intercommunication side by side in similar ways that our brains have neurons and synapses tied together. And because we own the design of this silicon, the market has defined Graphcore to be a semiconductor company. And although our secret sauce is indeed the design of our IPU, Graphcore is actually much more than just an AI processor company. To ensure that we maximize the potential of this IPU, Graphcore has also built and supply our own software that we name the Poplar software stack and development tools to program our IPUs. And together we deliver this IPU and our Poplar software in a 1U platform. It is called Bow 2000 as a plug and play for customers to simply install, deploy, and be thrilled. Bow 2000 can be stacked up to form rack scale products for scalable deployment from small numbers that can ramp up into tens of thousands of systems for supercomputing purposes. A little bit about Graphcore. We are quite well established by now, quite well funded, having raised more than $700 million so far. We have a very broad and impressive range of financial and strategic investors, including BMW, Dell, Microsoft, and Samsung. We are headquartered in Bristol, UK, which is the traditional hometown for British semiconductor startup. So Graphcore currently has about 650 staff across more than 10 cities around the globe. The Singapore office was just opened last year, and we are already attracting a lot of interest in the Southeast Asian market. So to the subject matter, machine intelligence evolution. So machine learning has been evolving very rapidly in the last few years. I'm sure all of you know this by now. Just a few years ago, we focused around convolutional neural network, right, where people were training models with a supervised learning approach that's defined by the use of labeled data sets to supervise algorithms into classifying data and predicting outcomes accurately. How to tell if a picture contains a cat, for example. And then more recently, models have evolved, right, to support transformer-based approaches, where we are training models with unsupervised learning approach, where machine learning algorithms analyze cluster unlabeled data sets. And these algorithms can discover hidden patterns in data without human intervention, learning the structure of language like NLP, or structures of pictures for vision transformer models, for example. And this creates the ability for much more complex, much more powerful models, because we have so much more unlabeled data, right? And the size of the models are getting larger as well. So the amount of compute keeps growing, and it has to grow exponentially to support these bigger and bigger models. But we know that this is not sustainable, right? So what we need to do is to move towards models which are much, much more complex, where the data can be steered towards the parameters that are relevant for those particular pieces of data. All right, what I'm trying to say is, rather than taking a whole block of data, what we need to do is sparse processing, where you can pick up and only process the relevant pieces of data against the relevant parameters in the model. And as you can see, right, this will require a very much more complex processor that has many, many individual processing elements that can all work well in parallel. So rather than working on large blocks of data, like, for example, how the GPU does, we need a processor that has many independent processor core that can deal with the complexities in data structure for these new generation models. So our IPU has been specifically designed to support this evolution in the way that AI is going to evolve. So let's consider the processors that are predominantly being used for machine learning today. We are familiar with a CPU. They were developed for scalar processing and running general purpose applications. The GPU was designed for graphics or vector processing. And in some cases, they have had additional core to help address some of the workloads specific to machine learning. But essentially, these are processors that were designed for a different purpose. By contrast, the Graphcore's IPU has been developed from the ground up specifically for machine intelligence workloads, and to enable a much more flexible approach to this newer type of machine learning models. The IPU with massive amount of parallel core that can do completely separate things to each other means that you can have different parts of the machine learning model that is doing different things to different data all at the same time. And this capability to do operations to different data at the same time cannot be efficiently implemented on legacy architecture like CPU or even GPU. Right. I want to dive down into a little bit more specifics. Right, a lot of customers ask, what exactly is so different about the IPU? So it's in two key aspects: the level of parallelism and how we maximize our memory access. So in the case of parallelism, as mentioned before, the CPU is a processor that was designed for scalar processing, supposed to run general purpose applications. GPU was designed for graphics. it has what we call a single instruction, multiple data architecture, where you basically have to put as much data into the vectors to make the most efficient use of those instructions. It is designed for large blocks of dense contiguous data. The IPU, however, is a massively parallel multiple instruction, multiple data processor architecture. It can be described as having a fine-grained architecture which is needed to address the trends towards more efficient machine learning models using smaller kernels. Right, and in the case of memory access, it really comes down to where your machine learning model and the data reside. Right, for CPUs, the data is typically in an off-chip memory with an average of say 140 gigabyte per second of memory bandwidth. And GPUs, they use state-of-the-art external memory systems like HBM2, improving the memory bandwidth to say about 700 gigabyte per second, which is approximately 5 to 7 times faster compared to CPU, right? And nowadays with a shared RAM on a GPU, you can see further improvement to maybe even more than 30 times better than CPU. However, if you really want to maximize your memory bandwidth, you need to put the memory on the chip itself, and you distribute this memory throughout the entire chip so that every compute tile on this chip has its own local memory. And this is exactly how we have done for the IPU, where the machine learning model and data is held in a tightly coupled SRAM right next to the compute or on the processor itself. And furthermore, we have attached a power delivery die on top of the IPU die, and this has also driven our energy costs down, delivering an astonishing 65 terabyte per second memory bandwidth, which is 380 times faster than a CPU. And this gives us a huge step up in memory bandwidth, which directly translates to raw performance. Right, so inside the IPU, we have been able to fit an unprecedented 900 megabyte of ultra high-speed RAM that runs at the full speed of the machine. I want to elaborate this a bit because this is quite important. The nature of AI compute, right, is massive numbers of matrix multiplication operation and then exchange of weights or data. And this is an incredibly memory intensive activity where you are constantly reading from and writing to memory, which is pretty much at the heart of what AI computing is all about. So it follows then that if you have a huge amount of available memory on the same silicon as your processor core, you divide up this memory equally across this core, place it right beside the cores, and then the time taken to perform the read-write operations will drop drastically. If you multiply up all the times that this is happening, hundreds of millions and billions of times, and all the microseconds of saving each time, you will just translate into savings of minutes, hours, and even days, taken to train workloads. And this is why it is important. Right, so Graphcore's third generation IPU, the Bow IPU, that's our name for it, has 59.4 billion transistors and 1,472 independent processor core. Each core can run 6 independent program threads in parallel, meaning one IPU can give us nearly 9,000 independent parallel program threads running on the proven multiple instruction, multiple data processor architecture. On top of that, we have taken 900 megabyte of ultra-fast SRAM, and we split it across the entire chip right next to each of the 1,472 compute tile, right? And now because each compute tile has a little bit of its own local memory just residing next to it, the memory bandwidth is an astonishing 65 terabyte per second. And if you look at the picture here, right, you can see the red color bits, which are the 1,472 independent core, and the pink color bits are the little bit of 900 megabyte of ultra fast SRAM that we have split across evenly next to each tile. And tile to tile can communicate. Tile to tile exchange is 11 terabyte per second, multicast, unicast, broadcast, non-blocking any communication pattern. That is to say, any tile or any group of tiles can communicate to any other tile during the communication phase. And one IPU alone is capable of 350 teraflop of AI floating point capability. The IPU is also the world's first 3D wafer-on-wafer processor. In fact, we are the first company in the world to use wafer-on-wafer technology, a pioneering process that's developed by TSMC. With wafer-on-wafer, 2 dies are stacked at the wafer level. One Colossus die for AI processing and a second power delivery die. So by adding a layer of deep trench capacitors in the power delivery die, right next to the processing core and memory, we're able to deliver power much more efficiently. The IPU machine is a very, very pure distributed parallel processor that consists of many high-performance independent processor core, right? Each with their own local memory, as I've just explained. So each of these can actually send message to each other through a perfectly stateless interconnect. And this interconnect allows the IPU to support any type of knowledge model, any type of inference algorithm, even ones that we haven't even thought of yet. And the static nature of the computation graph allows a compiler to divide the program into independent subprograms running on the many, many processor core. But we need a mechanism to maintain overall program order so that these messages can be sent between the subprograms at the right time. Right. So there's a paradigm for doing this. It's called bulk synchronous parallel that works by alternating between a compute phase in which all the processor just does compute in its own local memory and an exchange phase in which they just send and receive messages, memory to memory. The beauty of this bulk synchronous parallel is that it effectively creates a sequential machine at the whole program level, but it supports massive parallelism in each of the steps, automatically free of concurrency hazards, so you cannot write a program with deadlock or live locks. Right? And this sequence of compute and exchange phase is extracted from the graph automatically by the compiler. So this whole BSP mechanics is not something that the programmer needs to think about. It is just the IPU way of mapping a graph program to an efficient, scalable, and massively parallel machine. In his interview with Wired Magazine, Jeff Hinton, one of the leading pioneers of deep learning, highlighted that Graphcore's IPU has delivered the new type of compute that will be required for next generation of machine learning systems. And now I'd like to showcase our IPU and our Bow platform here in a very short video. So all of these new breakthroughs have come together in a single revolutionary product. It's what we call a Bow 2000. Bow 2000 is a machine that has 4 IPU engine, meaning 4 of our new Bow IPU processor, combined with a very advanced airflow cooling system to fit in a very easy to handle 1U chassis. It can be easily added into any existing converged infrastructure data center with its own dedicated AI-focused IPU fabric networking inside the box. Right. These IPU engines are also combined with another additional IPU fabric chip, allowing multiple BO 2000s to be added in the rack, or racks of BO 2000s to be connected together to build large IPU ports, which are all supported by what we call a exchange memory system. I'd like to spend a minute here to talk about the exchange memory, how it works and what makes it special. If you look at the graphic here, you can see there are two DRAM cards that's installed inside a BO 2000 chassis. So exchange memory essentially comprises of two different types of memory that are used for different purpose. As I introduced earlier, each IPU already has 900 megabyte of ultra-fast in-processor memory. So a BO machine like this with 4 IPU will have 3.6 gigabyte of in-processor memory in total. Right, and in-processor memory is part of the IPU die itself, evenly distributed across all the compute tiles. Memory bandwidth here is ultra-fast, 65 terabyte per IPU. Right, actual machine learning model itself is contained in the in-processor memory, along with weights and activations. And basically all the things that are most active that you use most often will be stored in the in-processor memory inside the IPU. A good reference point for thinking about in-processor memory is actually the perfect cache, because it works holistically with our Poplar software at compile time. That means all the values that are planned to be used during the session is readily there in known locations, so there is no such thing as cache misses on the IPU. Right. The second element of exchange memory is that we have a very large streaming memory capacity with the installed DRAM inside the BO 2000 chassis. It offers a great flexibility to store supplementary model elements, things that the model needs to access during training. And because this streaming memory has such a large capacity at 448 gigabyte, right, it offers a disaggregation benefit from the x86 servers, because you don't need to have so many requests to the host server during a workload, right? So the machine learning model is stored in the in-processor memory, and all other data that you need during training resides very locally in the DRAMs as streaming memory. And this is what the entire range looks like, extremely scalable, where users can scale up from one BO 2000 providing 1.4 petaflop of AI compute, just one machine, right, to a BO Port 16, which is basically 4 BO 2000 machine consisting of 16 IPU, providing 5.6 petaflop. And then you can scale out massively, Port 32, Port 64, 256, and beyond, to even supercomputing scale of exaflop. At this point, I just want to highlight an important fact that the BO 2000 is not a server. These BO ports will need to be directly attached or via a switch to an industry standard server, let's say from Dell or HPE or Lenovo, in order to load the software to program the IPUs. As to how many servers you need, it really depends on what you intend to do. Right? Most language AI models may require only one server, while some very intensive computer vision models may require a lot of servers. But what I want to highlight here is that the server to IPU machine ratio is disaggregated. There is no one fixed ratio of one server to one IPU machine, right? To elaborate, what I mean is that, our fully scalable system allows you to add host servers according to the model needs. So you can derive the optimal server to IPU ratio. Whereas in our competitor's machine, the DGX 800, that ratio is fixed. And we know that one size does not fit all. Right, so I want to take a quick 30-second look at how a IPU port 64 reference design is connected up in practice. There's some slight variance, obviously, depending on how many host servers you wish to employ. The number of servers is predominantly based on the type of workloads you expect to run. But the fundamental components of the entire system are 16 BO machines, one 100 gigabit Ethernet top of the rack switch, one 1 gigabit Ethernet management switch, and one approved host server, could be from Dell or HP or Lenovo, right? So most of this IPU communication happens through standard 100 gigabit Ethernet cables connected in a 2D torus ring topology, which is very good for all reduce all gather kind of operations. Right, so I just want to switch gear and talk a little bit about software because actually software is just as important, if not even more important than the hardware itself. So introducing our Poplar SDK, which enables us to program IPUs to build machine intelligence application. Right, our Poplar SDK is built from a few key components. The highest level, the machine learning frameworks like PyTorch and TensorFlow, which means that you can use the model code that you already written in those frameworks. Very minimal code changes, and you can port your model to run on the IPUs. Poplar contains podlibs, which are libraries containing higher level mathematical and machine learning functions. They are required for the implementation of your machine learning models, things like matmos, convolutions, random number generation, etc. Right. And the graph compiler and the graph engine performs the core runtime capability of the Poplar platform. And our Poplar software also integrates seamlessly with orchestration software like Slurm and Kubernetes. And our hardware management software uses reliable open source software with OpenBMC and Redfish. Poplar is the core software that we use to program IPUs. It consists of the graph library, the graph compiler, and the graph engine. Graph library is just a very simple C++ graph building API. It allows us to specify a computational graph, execute any application on the IPU. It is also used as a target for machine learning frameworks to integrate with Poplar. Next, we have a graph compiler, which takes our computational graph and maps it on the IPU system. And once the application is compiled, we execute it on the IPU using the graph engine functionality, which provides a very high performance graph runtime for interfacing efficiently with the host. Sorry. So for the machine learning frameworks, we do supply our own branch of TensorFlow that supports the IPUs. We have a fully performant integration with TensorFlow XLA, and this enables compiled backend for TensorFlow to target the IPU directly via Poplar. We support both TensorFlow 1 and TensorFlow 2. We also enable native PyTorch models to run directly on the IPUs using our PopTorch, which is just a set of extensions for PyTorch. Right? PopTorch supports both inference and training. And to run a model on the IPU, you just need to wrap your existing PyTorch model in either a PopTorch inference or a training wrapper. And we also support multi-IPU primitives from PyTorch models. PopArt is our Poplar advanced runtime for inference and training. It supports ONNX model input, so you can load the ONNX model and run it on IPUs. For machine learning engineers who like to build their own models in the IPU directly, PopArt also supports model building using either Python or C++ interface, because it is a highly optimized lightweight application runtime for deployment. So a very simple example here, a real life customer example when he tries to port a model from GPU to IPU, right? Changes are typically very minimal. In this example, in order to port a Keras sequential model, we just need to import the IPU specific Python module, and then we replace the standard Keras model class with the IPU optimized one. This takes care of things like infeeds and training loop. And finally, you just need to configure the IPU system and put the training graph on the IPU. Very simple 3 steps. Right, so we are very thrilled that PyTorch Lightning now also supports Graphcore IPU. We are very, very supportive of PyTorch Lightning's mission to meet the growing demands from the AI research community for flexible and fast AI compute solution. So PyTorch Lightning, as we know, it liberates data scientists from heavy engineering duties such as loops management, data distribution, logging, handling, and so much more. It allows us to focus on modeling and data understanding. All right, so this integration basically means that PyTorch Lightning users can now take any PyTorch models for the IPU and use our PopTorch API to run them with very minimal code changes and get the same high performance. All right, this slide is what I like to call state-of-the-art models meeting state-of-the-art hardware. Graphcore and Hugging Face are 2 companies with a common goal: to make it easier for innovators to harness the power of machine intelligence. Right, Hugging Face hardware partner program will allow developers using Graphcore systems to deploy state-of-the-art transformer models optimized for our IPU at production scale with minimum coding complexity. Today, Poplar is also available for developers to access through our Docker Hub, with Graphcore joining Docker's verified public verified publisher program. So together with Docker, we are distributing our software stack as container images, enabling developers to easily build, manage, deploy machine learning applications on Graphcore IPU systems. Popular libraries are also provided with more than 50 optimized functions for common machine learning models built on top of more than 750 high-performance compute elements. Right, so these libraries ensure that we can target the IPU efficiently from the machine learning frameworks. And here you can see a list of all the libraries. They map the functions required to the IPU underneath very efficiently. Right. At the bottom, you can see the visualization of the Poplar graph compiler intermediate representation for 4 different types of map modes. Right. Each of the op graph layout is specialized depending on its inputs and outputs for maximum performance. For those of you developers who are interested to learn more and dive deeper into Poplar, I encourage you to visit this website for a full range of tutorials where you find code examples, API references, and community support. And if you go to GitHub directly, this is where you find our code, and we're definitely open sourced, and we welcome code contributions from the wider machine learning community. Switching gear now to talk about something a bit lighter, is about the market and the industry and some of the customer use cases. So what kind of markets and industry are we targeting? Right. Here we see a number of vertical markets that utilize machine intelligence workloads. They are proving to be very suitable for the IPU. Right. Data center, consumer internet uses machine learning extensively. An IPU is used in a variety of research and recommendation use cases. Right? In the field of research and higher education, we have a huge number of universities and institutions. They are already seeing very large performance benefits in their simulation and research works. And we'll see shortly the IPU is being used in multiple healthcare applications such as medical diagnosis and drug discovery. Finance is also a market where IPU is enabling innovation in many fields such as trading, forecasting, insurance. There's also a whole new market that we call AI first, whereas the name suggests, right, AI technology dictates their entire business model, such as automotive and also smart city initiatives. These are some of Graphcore's customers. It is my goal to actually see a full page of customers from Indonesia by next year. Right. So many of these customers have used Graphcore's IPU to do some very groundbreaking work in AI. And I just want to show a few of these case studies in the next few slides. Researchers at the Oxford Mann Institute of Quantitative Finance have used Graphcore's IPU to dramatically accelerate the training of advanced price prediction models using techniques which are typically plagued by computational bottlenecks when run on other types of processor. The IPUs designed for AI architecture allowed the Oxford Mann Institute team to reduce training times for their multi-horizon forecasting models to a point where they could deliver significant commercial advantage by more accurately estimating market price movements. And such models can be used in the development of alpha for fast trading and in market making strategies. Another example in the finance industry, but this time using computer vision models. Tractable is an AI company in UK that uses AI for accident and natural disaster recovery. They do it by connecting the policyholder, the insurer, the body shop, and the contractor, and make them collaborate to get the car fixed a lot more efficiently. So what they do is that their systems look at the photos of the damage and decide if the car can be fixed. Right? And if the car can be fixed, they can tell they can figure out which body shop it should be directed to, where it can be fixed most efficiently. And once the car is inside the body shop, they can help the body shop to decide what type of parts they should order and where they should order it from, and align all this with the insurer. Right, so their processing pipeline uses several techniques. For example, efficient net-based models are used to process images, which feeds an attention-based model. And they have evaluated Graphcore against their current training regime and saw a 5 times speed gain. This means that what they used to take a week to do now only takes a day. The Sensoro environmental, social, and government solution for ecological ecosystem protection, citizen safety, environmental health, animal welfare, and climate emergency response includes things like smart fire protection. So the rapid growth of the use of electric bicycles have seen an increase in e-bike charging fire. So Sensoro's monitoring system can alert building managers to the arrival of e-bike at their premise, allowing them to assist with safe charging procedure and facilities. Emergency flood prevention. Sensoro is using Graphcore IPU systems to develop early warning systems based on monitoring of urban flood risk, enabling better disaster preparedness and emergency response. Smart ecological governance. So illegal river fishing breaks the ecological food chain and destroys the integrity of the river ecosystem. So using IPU systems, Sensoro is able to recognize different fishing scenarios, such as electric fishing or net fishing, providing accurate information on illegal fishing activity. Shifting attention to the healthcare industry, right here is a summary of some of the work by Microsoft on chest X-ray diagnosis for COVID-19 using efficient net model. So accuracy is extremely critical in this diagnostic healthcare use case, and a research paper has shown that moving to efficient net resulted in significant gains in accuracy to well over 90%. However, the efficient net model just ran too slowly on existing, GPU architecture to be practically used. So the Microsoft researchers were able to easily port the model to the IPU with our popular tools, and out of the box found a 12 times speed gain in throughput versus GPU and faster time to train. Only in the last couple of years have we started to see the first AI designed small molecule enter clinical trials. So making this a whole new era for drug discovery. So today, this organization, Lab Genius, is focused on accelerating discovery of advanced treatments for cancer. But their principles can be applied far more widely as well. So Lab Genius uses Graphcore IPU compute to accelerate the training of BERT. They found it simple to use an off-the-shelf PyTorch version of the transformer model BERT optimized for IPU with our code freely available on Graphcore's Git site hub. The researchers at Lab Genius took a large body of known protein and asked BERT to predict amino acids from training data. And the fact that our IPUs were able to cut the training time so dramatically on a model that needs to be repeatedly retrained gives Lab Genius a substantial advantage in a competitive industry. So Lab Genius is also now looking to expand the use of Graphcore trained BERT models, including further use within the discovery phase. And in addition, it is also starting to explore building new AI models on Graphcore systems, including graph neural networks. So high performance computing is an essential tool fueling the advance of computational science, right? AI is increasingly being used alongside traditional HPC techniques to run large-scale simulations in an accelerated time frame. The European Centre for Medium-Range Weather Forecasting has developed a number of deep learning models as part of a publication investigating the use of machine learning in numerical weather forecasting. So Graphcore engineers took one of the center's publicly available forecasting models, a multi-layer perceptron, and ran it on an IPU with dramatic results, obtaining 5 times speed up chip for chip in training throughput over a leading GPU without any optimization or modification or any hyperparameters. So IPU has been used across many areas of research in industries and academic institutions around the world. Here we see some examples of published research papers and press articles. Right? For example, the University of Bristol has benefited from IPU's highly parallel compute in their research on CERN's Large Hadron Collider experiment, with more than 5 times faster performance for their generative adversarial network application. In another example, researchers at University of Paris published a paper about the use of Graphcore to accelerate neural network training for cosmology applications. Here's the list of some of the universities and research institutes around the globe that we have collaborated with Graphcore and published research papers. In fact, we have a much longer list than this, but I just ran out of space to squeeze all the universities into this presentation. I'd like to spend the last 5 minutes to check out our performance benchmarks to see the gains that our customers are seeing in different market verticals deploying the IPU. So Graphcore has participated in machine learning MLPerf with some very impressive results. And all these results are publicly available for machine learning enthusiasts to review on our website. And in the interest of time, I will not go through all the results, but I just like to highlight a few key messages here. Firstly, we release new versions of our popular SDK every 3 months, and that has resulted in performance improvement leaps, even while our hardware remains the same. So you can see here how our version 1.1 results compare versus our first submission on version 1.0 just 6 months ago. On ResNet, for example, we had a huge 24% improvement for our port 16 and a whopping 41% for port 64. And for BERT, we had improvements of between 5 to 12% for different port configurations. And this is all just because of improvements in our popular SDK. The hardware has actually remained exactly the same. The other thing worth highlighting is our results versus competitor. Right here, we show the results for our IPU port 16 platform compared to NVIDIA's flagship DGX 800. As we mentioned, our performance has increased significantly since the last MLPerf submission by more than 24%. What this means is actually our IPU port 16 is now even faster than the DGX 800. And this is even more impressive given that our list price of a port 16 is approximately only half that of a DGX 800. And if you take a look at the efficient net, right, here we show our time to train results for our port platform and compare those against NVIDIA's DGX 800. Our port 16, which is our second generation IPU platform, managed at under 21 hours time to train, compared to 70 hours on a DGX 800. And with the launch of our Bow platform, we saw even larger advantage, right? Now, in the case of EfficientNet B4, our Bow port platform is 5 times faster to train. So all these performance benchmarks are published on our website for public consumption. By providing them in a published results table along with configuration and parameters used, we allow our customers and partners to use these results to do their own analysis and comparison. The number of examples we are building out is growing. So here we have new applications around GPT, vision transformer, speech models, even AI and HPC acceleration. And for customers who like to have a quick try on the IPU themselves, Graphcore and Spell are offering a self-guided free trial, enabling developers to instantly root test our IPU with a range of very popular AI models on Jupyter Notebook. So Spell is a machine learning ops platform that operationalizes deep learning for NLP, computer vision, and speech recognition at scale. And you can see a screenshot here of someone fine-tuning BERT example here. Should you have any particular models you like to run on the IPU and you like to see some throughput, you like to see some accuracy results, we can also arrange a free 2 weeks trial with one of our cloud partners shown here, where our engineering team will be able to guide you to port your current model to the IPU instance and try any optimizations that you like to play with. Right, with that, I'd like to close by announcing the Good Computer by Graphcore. Starting from a single cell and shaped by 4 billion years of evolution, our human brain is perhaps nature's greatest achievement. Our brain is an incredibly complex computing device with approximately 100 billion neurons and more than 100 trillion parameters in a biological neural network system that delivers a level of compute yet to be matched by any silicon computers. And today we are revealing that Graphcore is developing an ultra-intelligence AI computer that will surpass the parametric capacity of the brain. The computer science pioneer Jack Good was the first person to describe such a machine that would exceed the capability of our brain back in 1965. So named in honor of Jack Good, Graphcore will deliver by 2024 the world's first ultra-intelligence AI computer that we're going to name as the Good computer. And following on from our announcement from the Bow IPU products, we are already developing the next generation of IPU technology that will power this good machine to deliver the following capabilities: more than 10 exaflops of AI floating point compute, up to 4 petabytes of memory with a bandwidth of over 10 petabytes per second, support AI model sizes of 500 trillion parameters, 3D wafer-on-wafer logic stack, and is fully supported by our Poplar SDK. We'll provide further updates on the Good computer over the coming quarters, and we are keen to engage with companies and AI innovators who can help us develop the next breakthrough in AI that these ultra-intelligent machines can make possible. Here in Indonesia, we are very excited to be working with PT Sistek Charisma as our distributor for this advanced AI compute that we hope to introduce to the AI community. And very thankful to Pak Adi from Indonesia AI Society for inviting us to today's session. I hope it was informative for everyone. AI compute is still at the very early stages of an extremely large market that we believe will be booming in the coming years. So should there be any questions or inquiries, please feel free to reach out to myself. My email is here, or you can also reach out to Sistek in Indonesia, and we'll be very happy to schedule a private discussion. With that, I wish all of you a very good evening and a very enjoyable weekend ahead. Back to you, Pak Fanky.
Yes, thank you, Philip. Okay. Yeah, okay, let's go for the Q&A session. I invite Vijay to join the spotlight. Okay. Okay, I already have some question. Bapak Ibu rekan-rekan silakan kalau ada yang masih mau bertanya di kolom chat ya. Nanti setelah chat habis dibahas kita bisa langsung direct question juga ya. Oke, I will try to see the question. Number one is from Pak Farid Ahmad. Yeah. How to test the system if there is a faulty business in one of the framework made from the artificial intelligence in Arogya AI? Is the system integrated with the canary system? Vijay.
Sorry, what's the question?
How to test the system if there is a faulty business in one of the framework made from the artificial intelligence in Arogya AI. Is the system integrated with the canary system?
Okay, I don't know I don't have the answer to the second part of the question, but to the first part of the question. So we have a forecasting model based on consumption, based on daily transactions, etc. And the algorithm outputs numbers as to how much are you overstock, how much are you understock. So it's a demand sensing model based on all past patterns and behaviors. So having said that, things can change, patterns can change, but the accuracy of what is coming out as an output is in close to 95 to 96%. When we started off 2 years ago, when we were training our model, when we were looking at all of the data that we were receiving, the predictions were pretty much around 80 to 85 to 70, between 75 and 85%. And since then, we have upped it up to 96 to 95 to 96%. Now here is and thank you for the question first and foremost. Here is one very important aspect of it. We ask that hospitals, when we are looking at hospital data, we ask that they provide us at least 3 years of data. The reason being this is we would like to see the data 1 year before COVID started, a couple of years during COVID, and a year after COVID. That gives us a broad range of data to make sure, otherwise our learning, so we use the 70-30 rule or the 60-40 rule for training data, testing data, so on and so forth, right? So if I were to take 2018, I've even forgotten when COVID started. I think it started 2019, right?
Yeah.
Right, Philip? So we have all forgotten when it started, how many years we have been in COVID. Right? So if I take the previous data and then I train and test it and ask it to predict within a quarter after COVID started, all my algos will just say that no, this is not what it is. This is a completely different pattern than what we saw there. So yeah, so it's a combination of doing it, and as time passes by and data gets normalized after all of this is done, I think the errors will generally reduce. But we have also taken into consideration of what are sensitive drugs. And here is the nice thing. Sensitive drugs, which are generally used on a day-to-day basis, did not see any much changes during the COVID outbreak. So those patterns continued to be whatever they are, and we didn't see any difference. So yeah, I think that's, I can go on, but that generally is the answer for your question. There will be errors, we will learn, we will train it, but none of them are life-threatening or hospital operational threatening. So yep, that's the answer.
Yeah, thank you. So it means that for make it at least 3 years of data, yeah, Vijay?
Yeah.
Okay. The next question from Pak Arif Rahmadi: what is the biggest obstacle to implement AI technology in healthcare?
In
healthcare.
In ASEAN.
Yeah.
Healthcare.
In ASEAN, healthcare in ASEAN or in Indonesia, perhaps you have.
It's kind of a very tricky question, and sometimes AI, we have to be very politically correct, right? So, yeah. So well, let me throw out a very generalized statement, which is beneficial to all of us. Is changes in technology are not that well accepted very quickly. And as some wise men once said, that usually with technology, we are very optimistic in the long term and very pessimistic in the short term, right? So, hey, this will work, this will not work, and oh, this will happen, that will happen. They paint a very global picture. And I think AI is going through this phase. And I think Philip will also second me on this. And they like it, but their questions is around adaptation, and not even at and the best part about it is cost is not a matter. They don't even think about cost. They're thinking about implementation. How do I manage it? Do we have the workforce? What happens if your company goes away? Then what do I do, etc., etc. So yeah, those are some of the broad speaking challenges in AI and its adaptation.
Yeah. Even in the healthcare industry, I think one of the most growing sector, during the pandemic, Vijay.
Yeah.
Okay. But I think it's also related, because in Indonesia we have in healthcare industry or even in government, they have a strategy, the digital transformation strategy, which is involved the AI as a part of the journey. Okay. The next question from Pananang Diagraha. How are AI maturity, implementation, and effectiveness, and how the healthcare stack up against the average across all industry? the AI maturity and the implementation. Yang perspective, Vijay.
Before I answer the question, let me tell Philip. Philip, I don't think you are going to have many questions because
it's good. I'm enjoying this.
No, I will ask Philip the same question.
I have a lot of questions for you, Philip, but I'll catch up with you separately. But looking at all of it, I have a hardware background actually. I'm an electronics engineer. I've been dealing with, so before I became a software engineer, I was a hardware engineer. So
that's good. That's
all of that. Yeah, so that's yeah. So quite a lot of research and development has gone into my hardware and software stuff, and I'm very impressed with what you have presented. So I will definitely catch up with you. AI implementation, right? Both as people are very, very interested. But so the question is, are they willing to experiment with their interest? That's the barrier, right? Are they willing to interest? Because let me put it in another way. AI is not a standalone system. It requires a lot of community effort, a lot of, right from the manager, from the CEO, from the directors, right up to the people, the staff, the hardware engineers, the software engineers. So it requires everybody's involvement. But are they willing to put in the time, the effort to see progress? That is something that has to philosophically change, right? It has to substantially change. And I think so the better way to ask that question is that inflection point happening, or will it happen soon, or has it already happened? I think the interest is there, but the inflection point has not been reached. So what I do is I put in the FUD factor, that is the fear, uncertainty, and doubt. I tell them, and it's one fine day, let's put it this way. There is a healthcare provider 1, there's a healthcare provider 2. The healthcare provider 1 can afford to provide that healthcare services at 50% and the cost. What happens to healthcare provider 2? The healthcare provider 2 is now going to ask, how is he providing that at 50% the cost? And then they say they have Arogya, we don't have Arogya, this thing is costing this much, this is costing this much. So we are looking at a very competitive market to change the dynamics of this industry. But will it happen soon? Is there going to be an inflection point? I don't know. I can't predict it. When will it happen? I don't know. We hope it happens. Right?
Okay, Phillips, what do you want to add something?
Sorry, what was the question?
AI maturity and implementation.
Okay, I think from my side, it's really just based on personal experience, because I've been talking to some customers. I realized that, as what Vijay said, there's a lot of experiment going on. I certainly don't think the inflection point is anywhere near. In fact, I see that only the really big companies are investing on machine learning engineers and hardware, and all these are not cheap. And the other thing is also talent. The search for talent. When I tried to hire my first engineer, I actually had to take like 3 months, because there's not a lot of machine learning talent pool available in Southeast Asia. It's not easy to find, and when the talent is available, they usually get snatched up by the very large corporations who have very big AI labs. So that is also a problem. That's why I'm very encouraged to see such a big crowd here today of AI practitioners for Indonesia. But that is also one of the points that might slow the inflection point if there are not enough talent to go into this market as well.
Okay, thank you, Philip. Okay, the next question from Pak Nanang. Okay, what is the importance of AI to the future of the healthcare organization? Vijay.
What's that? Sorry.
What is the importance of AI to the future of the healthcare organization?
the future of AI, as I said, AI is surely and slowly, it is just like asking about technology, right? It is how important. So when people let me make this a fun answer. So when the first X-ray came in and they could see the chest and the lungs and so on and so forth, when the first blood test results came in through the microscope, counting the total number of blood cells and so on and so forth. So from there to here, nobody asked at that point in time or couldn't believe how important all of these parameters were, to understand what it is. Now let me throw something at you, completely different. X-rays, as we know, are done by light. Technology and AI are now coming up, changing X-rays from light into sound. And we already know that, right? What is it called? The fetal monitor and the sound sonar. So you can look at the heartbeat and the shape through sonar, right? You can't use an X-ray on a baby. So they use sonar on getting it. Now that sonar machine is very big. It's a huge machine. It's not small, right? When it renders it. But guess what? Thanks to AI and thanks to people like Philip Tan who are miniaturizing all of these technologies, you can now have that thing in a small wand. It can now connect to your iPhone and it can show you your knees, the knee, you can show you your thumb. You can literally see your entire thing using sonar on your iPhone.
Yeah.
So that's the change in technology. Now, if somebody asks, what can it be used for? Is it going to change the way we do medicine? I think yes, and many people will be skeptical. So what can AI do in this is a very broad question, and only time will tell. But I can tell you this much, that 2025 will be completely different from 2022.
Yeah. That's agree. Okay.
Yeah, and as Philip pointed out, right, the requirement for that kind of compute power, cheaper, faster, scalable, is going to be by factors, not in an arithmetic progression, but in geometric progression. Not linearly increasing, but geometrically increasing as years and months go by. And I think Philip is in the right framework to manufacture something like that.
Yeah.
And it will truly help the industry.
Okay. The next question from Krishna. How to prepare an organization to be data ready for AI? Vijay, you said for healthcare, at least 3 years, right? How to prepare an organization to be a data ready for AI?
Right. So that's a very big transition. So most of the systems, most of the organizations, whether it is healthcare and all over the world, so believe it or not, PwC and some other companies are predicting, and actually some of these big four are creating business verticals which are completely based on data for law firms, for healthcare. So they are getting into what is called as data science, not from a perspective of doing data science, but consulting to create AI-ready data, which is not simple. Ask me, it's one of the most difficult. Really on the side, that as Philip was showing about sparse data, about all of the data, to streamline that data to be consumed by an AI engine is not an easy task. It is difficult, and such data scientists and such algorithms to actually look at data and formulate them, it's going to take time. But companies like mine, companies like Philip are there to help them to get that and see how they can optimize on these on our experience and our expertise.
Yeah. So it means that the organization cannot prepare the data by their own. They still need someone else like you to help them to prepare the data.
They can, but it's costly, and as Philip said, they have to hire people, and they have to do all of that. So it's a big thing. It's a big thing, and rather than that, just outsource it to a company like ours, and we have the expertise, and we can do it very easily. Because time is of essence. So if a hospital as of today would like to standardize their data or get their data to be AI ready, as we call it, into a time series and all of that, and structure it, what will be their cost? I can give you the numbers. I can tell you the numbers. What will be their cost? But if they ask Arogya to do it, and we help them do it, and it's based on getting it perfect, we are much more consistent. We are much more cheaper.
Yeah,
and it's a matter of viewpoints.
Especially the time. Yeah, I think also the most important things. Yeah, if you can make it faster, right? Time to implement, I think it's better, right? Compared, you have to develop your own team. It will take time. Yeah, but I think in EIS, we do have some concern about that. That's why one of the concern, we try to create these talents, start from the data science talents and everything. Okay, the next question, I think.
Fanky here. So thank you for that last statement. So Arogya truly believes in advancing education. So as we are doing our data science, and as we are getting it, because we benefit not from doing data science, we benefit from actually running our algorithms, products, services, and creating the network marketplace. So what we do is, as we are doing our data science to get your organization or any organization data ready, we train existing relational database managers and additional whatever you want to call them. We do train them, we do educate them, we tell them how feature engineering is done, how data is in a time series, how you to create it. So we do the education part of it as well.
Yeah. Okay, it's good if you have also the same concern. I think we can try to more engage and collaborate how we develop the talents.
Yeah.
Okay, I think Pak Krishna, the next question, Pak Krishna missed the first slide of the presentation. Any insight on what benefits of the healthcare provider can get the ROI, and how much saving etc. when they implement the, let's say, the Arogya AI?
Okay, so according to our studies, inventory constitutes around 40% of a hospital's revenue, big or small. 40% is tied up within their inventory. And we also have some data behind that the overheads for managing this. So if the revenue of a hospital is around, say, 1 million, for 400,000 plus is in inventory. And this is revolving. So they're using 400,000 and so on and so forth. So to manage that kind of inventory, the overheads that can be saved are almost 20%. 20%. So they are also, so you think about managing $1 million of inventory, and believe it or not, that $1 million of inventory is from Obat, which costs 6,000 rupiah.
Yeah.
10 cents, 20 cents. Now think about all of that constituting into $1 million. So we have created a graph of a hospital's inventory. So the very high-end inventory is so low that it's almost negligible. Most of the construction of the hospital is within that range of $1, $2, $5, $10. So all of that coming up together. So managing these small items, the wastage, the smaller the items get, the more it is wasted, the more it gets expired. So we help the hospitals not to waste it, so that drugs don't get expired. So all of this is net savings to the hospital. So we help them to improve their bottom line radically. So over a year, they can actually see somewhere around about 10 to 20% of savings.
Okay.
Directly, and from not wasting another 10 to 20%. So it's radical.
Agree. And also I think Indonesia, one of the complicated business is the hospital.
Yeah.
Yeah. Okay. Yeah, I think there are some other questions for Pak Philip actually. Let me see.
Nice.
Well, okay. What different SoC IPU and Altera FCPGA for EI from Pak Farid?
Sorry, can you just repeat the question?
What different SoC IPU?
Okay.
And Altera FCPGA for EI.
Okay, I think I know the question. So basically, I think it's asking the difference between what is the difference between the IPU and the SoC and the FGPA, right? So I think in the market there's a lot of AI accelerators. Some come in the form of SoC, some come in the form of FGPA. But I think a lot of the SoCs of the FGPA are actually the edge device, which means, for example, I'll give you a very simple example. I spoke to a sewing machine company, right? They make sewing machine. So inside a sewing machine, they are trying to inculcate AI. They will study your sewing pattern and things like that. So these are edge device where they will probably put a AI FGPA. Because it's small, it's cheap, and it doesn't do much of a training. It's really just to learn your behavior and to just inference some kind of behavior. But what in the IPU market is actually a little bit different. In the IPU market, we are very deep learning intensive. In fact, at this moment, we only have one competitor, and that is NVIDIA's DGX 800. Where we are training very large models. This machine cannot be put in the edge. It has to be in the data center because it takes up a lot of power. Not as much as NVIDIA, but still takes up a lot of power. And it is really predominantly used for deep learning training. It can be used for inference as well. But the main difference between IPU and FGPA is that FGPA usually is used when the customer doesn't know what they want to do yet. So you just put it there and then you can field program it when you know what to do with it. But for IPU, the customers are people who know exactly what they want to do, and usually it's used for machine learning training only.
I see. Okay. That's the answer, yeah, Pak Farid. Okay, the next question: how to benchmark BOW 2000 in the box?
Benchmark. Okay, so benchmark, as I mentioned just now, we have a whole list of benchmark that we took part in the ML ML Commons. So for most of the machine learning models that the very common ones like ResNet and NLP, all our benchmark results are already there. But if there are anything that you want to do it yourself, if there are models that we have not taken part in MLPerf, you want to benchmark it yourself, please drop me an email. We can arrange that. You can actually take our IPU on the cloud to do it yourself.
Oh, okay. So you have the facility on the cloud, right?
Yes.
That's good. So they can play.
Play with it.
Okay, good. Yeah. That's also because I believe, even in the cloud provider in Indonesia, I think we still don't have the GPU capabilities in Indonesia yet.
There's one or two, but I believe it belongs to the government. Yeah.
Yeah. Okay, the next question is from Pak Triwayu. I want to ask about the cost for the IPU. Is there any disclosed price for the IPU? If not, how it's compared to the GPU from NVIDIA such as A100?
Yep. I do have a price. Yes. In fact, for a DGX 800, the published list price is $299,000 US. I'm talking about the NVIDIA's machine, right? That's the NVIDIA's published list price. And for us, apple to apple comparison, same compute, our list price is about $160,000 US. So So if you can see
160.
160, so you can see that we are almost half price. Yeah, compared to our competitors.
That's a very interesting. Yeah. Okay. Wait. Yeah. All right. I think this is both of you can answer. Do we have any example of technical comparison between cloud-based AI processing platform versus non-cloud-based AI processing platform from Pak Arif?
Cloud processing, I think I mean, yeah, Vijay, feel free to add in, but from what I see, right, is depending on what, for example, today there are a lot of cloud providers like AWS or Google. They provide whether GPU or TPU, and now Graphcore is also providing IPU over the cloud, right? And in fact, a lot of new companies that want to play with this kind of thing, usually they may not buy first because it takes up space. You have to spend a few $100,000. So what they do is they subscribe instances from AWS or Google or whoever, and they just pay whatever they use. Obviously, I would say the difference between on-site and cloud, frankly, at this point, I wouldn't say there is any reason why there should be a lot of difference, because it's the same product, right? Maybe there will be very, very minute difference because of the latency, because you're doing it on site, your network is running better. But in terms of pure benchmark performance, I don't think there should be very, very big difference in terms of hardware performance.
To add to that, Philip, the question is, so is virtualization, so if we let's say that for 160,000, that's quite a lot of compute power that you're providing. So if I were to virtualize that into usable units, is that I see from your architecture that you need the server as a front end, which is basically the driver, and you are just providing me the
compute,
AI compute power. So will virtualization can be done right up to your stack, or does it stop?
Yes, you can. In fact, you can Dockerize it, right? Containerize it, and the fact that one IPU alone has 1,400 individual core, you can even treat one IPU as having 1,400 computer. You can. And you can run 9,000 threads. It's in fact it's better than virtualization.
yeah, exactly. Right at the core level. Okay. And also it can be charged. You can charge it per utilization. So all of that. It can also scale if it exceeds that, and if there are more parallel threads coming in, so we can assign more.
Because a lot of tasks, right, from what I see, right, a lot of language tasks or search and recommendation tasks, it takes about 2 to 3 weeks to train one model. So if that's all you want to do, obviously the smart choice is to just go and sign up a cloud instance, train for 3 weeks, maybe pay $20,000, and then that's it. But if you need to do it every day for so many different kind of models, obviously you want to have an on-site machine yourself.
Yeah. No, and the reason I'm asking is even in healthcare, right? So we receive from the API daily data of all the medications that were used, inventory that was used. Now, what we are doing is we are because retraining these models is very costly based on the new data set that we receive. So we have to timeline it as to when we are going to retrain it, and then what is the retraining parameters, when should it retrain it, what's the divergence between our prediction and what was already there. So all of that, right? So those questions. So if I get compute power for cheap without paying Amazon or somebody like that at very costly, because retraining is not an easy thing, right? Especially when we have 3 or 4 years of data, and then train and test it over a next period, next time horizon. Not going to be simple. So so agree. Okay, good. So we definitely need to talk.
Okay, one of my case also, I think there's at the time we do the face recognition in the software. So at the time I think we prefer put it on premise. compared to pushing the cloud, because it will, the data is not. The data is big. Indonesia bandwidth. We have some issue with the bandwidth and everything, right?
I think not only that. I think some government ministries also. I think they have some issue with putting data on
the
cloud.
Data localization. Okay, the last question from Pak Muhammad Nur Salam. How is the detail of the architecture of IPU?
Sorry, how is the? Can you repeat?
How is the detail of the architecture, IPU architecture?
How is the detail? Sorry, didn't quite understand the question.
The architecture of IPU, the detail of the architecture of the IPU.
Okay.
Is there any slides show the detailed architecture?
Yes. In fact, one of my slides earlier was actually quite detailed. So basically, it goes into exactly what we have put inside the processor, and basically now the processor is a 3D processor with two fabric die that we stack together. In fact, I don't think any other companies in the world have such a processor at this moment, not even the very big guys. I will share my slides. I think a couple of the slides in the earlier presentation have the very, very detailed processor architecture inside.
I think Pak Nur, you can rewind the video later to see the details. Okay, that's the final question that's entering in the chat. Is there any direct question? Bapak Ibu silakan kalau ada yang mau bertanya langsung bisa ya. Saya kasih kesempatan, silakan kalau apabila ada yang mau bertanya langsung kepada para speaker kita, Pak Vijay dan Pak Philip. Is there any question from floors?
What?
Good afternoon, Pak Vijay.
Yeah. Please.
This is Pak Arif ya Pak. I'm one of the follower of Pak Fanky Pak. Yeah. Pak Vijay, do you have any kind of example of AI-based fraud prevention in the healthcare insurance, Pak?
Oh, we are planning to go there. And so we have a complete detailed architecture as to how we are going to do that, how we are going to combine insurance, not only for the healthcare provider, not only for the patient, but also for insuring drugs and stuff in transit. Because especially when logistics provider, if you order 10 vials of penicillin and one gets broken, who is going to pay for it, right? So all those kinds of things can be, and also risk rating. So to answer your question, what stops us from doing insurance, right? It is data. It is risk rating. It is whether this logic is Gojek better than Grab, or is this driver better than Grab? If you are ordering it from Bluebird, who is much more safer to deliver this from this area to this area, right? And it also differs area by area. In Bandung, Gojek might be better. In Jakarta, Grab might be better. I'm using company names just as an example. Please do not use this as some specific data. This is big disclaimer. I do not have data at all regards these things. So that's my disclaimer, but I'm just using this as names. So yeah, that's what it is. So area by area, we can do a synthesis. So people can actually order, hey, this guy is better in this area. This guy is better in this area. Now, the other question to that is Indonesia and our businesses ready for that kind of analysis? Is it competitive? Is it non-competitive? Is it hurting, or is it beneficial? All of that are things that, and these are decision makers which higher ups can make, not us. But do we have the technology? Absolutely. Can we make that technology? Absolutely.
Okay, thank you.
Okay, thank you, Pak.
Ya, Pak Arif Rahmadi ini Indosat ya, Pak Arif ya. Oke, the next, ada lagi silakan Bapak Ibu rekan-rekan siapa yang mau bertanya? Direct question, silakan kalau ada yang mau bertanya. Ada yang mau bertanya langsung? Okay, I think no one want to ask again. Okay, directly. Okay, the closing. Okay, wait, yeah. Okay, before the closing remark, I hand over to Amanda first for the photo session. Amanda, go ahead.
Oke, Pak. Bapak, Ibu, rekan-rekan sekalian, silahkan aktifkan video kamera Anda, kita akan foto bersama.
Ayo, silakan buka kameranya, kita foto bersama. Silakan rekan-rekan, aktifkan kameranya, kita mau foto bersama.
Oke.
Udah, Amanda?
Oke. 1, 2, 3.
Thank you.
Sudah, Pak Fanky?
Okay. Okay. Now the closing remark start from Philip first. The closing remark, your closing remark.
Oh, sorry.
Yeah.
Didn't. So basically, I am just very thankful for today's opportunity. If there are any, I think AI compute is extremely new, extremely exciting. If there are any interest out there, on this type of technology, please feel free to reach out to me or my distributor in Indonesia, Systech Charisma. Thank you so much for your time.
Okay. Thank you, Mr. Philip Tan from Drucker. Next, Vijay.
Likewise, thank you very much for the invitation and the opportunity to speak to all the people, and also for the interest and all the questions that have been asked. I sincerely hope that AI, this forum brings about much more such conferences and inclusion. AI is coming, and I think groups like yours and your involvement will help it to get there faster. Thank you very much.
Thank you, Vijay. Baik, Bapak Ibu rekan-rekan, itulah akhir dari sesi kita. Terima kasih untuk kebersamaannya. Saya kembalikan ke Amanda untuk closing. Silakan.
Baik, Pak Fanky. Thank you for our speakers today, Mr. Vijay and Mr. Philip. Thank you untuk semua peserta yang sudah hadir pada siang hari ini. Jangan lupa untuk mengikuti webinar kami selanjutnya di minggu depan. Terima kasih, Tuhan memberkati. Stay safe, stay healthy. Thank you.
Thanks again, Philip. Thanks again, Vijay. See you.
Thank you. Bye.
Yeah, keep in touch. Keep in touch. Thank you.